Okay, start.
Assalamualaikum and hello everyone. So today we will have a presentation about SEL2 about topic Green's Theorem. So we are from group 2. So first, before we start our presentation, let me introduce my member first. So I am Muhammad Azfar bin Muhammad Arifin, Muhammad Huzaify bin Zulkifli, Ahmad Firdaus bin Muhammad Nazari, Noor Ain Zahirah binti Omar, and Nurul Fatihah binti Muhammad Razali. So let's move on to the introduction part.
Okay, I will explain the introduction part for Green's theorem. Okay, let's see is a simple closed curve and D be the region enclosed by the curve. Okay, if P and Q is a function that have a continuous first order partial derivatives on D, then the formula is integrate on C, P function dx plus q function dy equals to double integrate on d del q over del x minus del p over del y dA. As we can see on the graph on the right side, we must determine the curve is a closed curve, which shown in this graph. It is a closed curve because it start with at point 0, and end with at point 002. And the second properties is we need to make sure the curve is in the counterclockwise direction. That's all for the introduction. I will pass it to the next member.
Okay, I will talk about the question C. So the question we got, question C, it asks us to show that integrate NC square root 1 plus x to the power of 3 dx plus 2xy dy equal to 3. So where C is from vertical 0, 0, 1, 0, and 1, 3 oriented clockwise. Next slide. Okay, for the first step, we need to draw graph to find x and y interval. So for y, we got y equal to 3x and y equal to 0. So then we got 0 less than y less than 3x. So for x interval, we got x equal to 1, x equal to 0. So then x less than 1. Okay, for the next slide. Okay, step 2, it's based on Green's theorem formula, integrate p dx plus q dy. So first we need to identify p and q. The question is integrate square root 1 plus x3 dx plus 2xy dy. So for p it is 1 plus x3. So for q it is 2xy. And then we differentiate p and q with respect to y and x respectively. So p we got 1 plus x square root of 1 plus x3. So then delta p over delta y we got equal to 0. Q equal to xy. Delta q over delta x equal to 2y. Okay. Next, I will pass to the next person.
Okay, thank you, Zaifi. For 3, if we refer to the Green's theorems, the general formula is integrate p dx plus q dx like the slide before. So we just sub the calculation that we have differentiate into this formula, the general formula. So double integrate dq minus dx, dq over dx minus dp over dy delta a. So double integrate 2y minus 0. This is the answer that we have calculated before. So 2y minus 0 is 2y. Okay, next slide. Okay, for the step 4, So we just continue integrate as usual. So double integrate from the limit 0, 1, from the x equal to 0 to x equal to 1 and y equal to 0 and y equal to 3x to y dy dx. So firstly, we are going to integrate the terms of dy first. So we means the limit from 0 to 3x. Okay. So we integrate 2y will become 2y squared over 2 from the limit 0 to 3x, and then we sub the 0 and 3x into the equation. So it will become y squared. I'm sorry. We just simplify this fraction and become y squared. So then we sub the 0 and 3x, it will become 3x squared. And then we integrate for the dx from the limit 0 to 1, and it will become 9x cubed over 3. And then we just sub the limit from 0 to 1 in the equation, and then we get 3 1 cube minus 3 0 cube, and the answer is 3. So the question is shown. So that's all. I will pass to the next presenter. Thank you.
Okay, for the question 4, the question asks, the curve C is shown below, which is the shape of trapezium. Evaluate, integrate on C, 6y minus 9x dy minus xy minus x cubed dx. As firstly, we must determine that it is a closed curve, and so it is closed curve because the slide before, please. Because it starts with 0.1 minus 1 and ends at the same point. Okay, next. Okay, for the step 1, the Green's theorem formula is integrate p dx plus q dy. First, we must identify the p and q function. In this case, we found that p is a xy minus x cubed and q is 6y minus 9x. Okay, firstly, we must differentiate q with respect of x, which we get negative 9, and we differentiate p with respect of y, and we get minus x. And that's all. I will pass the presentation to the next member.
Okay, so for the next step, here we will need to find the x and y interval. So first step, we will use the Green theorem, which is the integration of p dx plus p dy is equal to double integral delta q over delta x minus delta p over delta y dA. So we will plug in the differentiation that has been done in the step 1 just now into this formula, and we will get the double integral negative 9 minus negative x dA. And lastly, we will get the double integral x minus 9 dA. So for the range of the x and y, we will use the formula y equal to mx plus b. So here we need to find the gradient of the line here. So m is equal to 4 minus 2 over negative 1 minus negative 1. So we will get negative 1. So we will get y equal to 3 minus x. So therefore, we will get the range of the x and y for the bound of the double integral, which is x is between negative 1 and 1, and also bound for the y is negative 1 and 3 minus x. So I think that is all from the step 2. I will pass to the next presenter.
Okay, for the final step, step three, we need to evaluate integration of 6y minus 9x dy minus yx minus x cubed dx. So from step 2, we have known that x interval is from -1 to 1 and y interval is from -1 to 3 minus x. And from the Green's theorem, we got x minus 9 dA. So we know that the inner integral is y, so we need to integrate in terms of y first. After we integrate in terms of y first, we got xy minus 9y from the limit -1 to 3 minus x dx. And then we get negative x squared plus 13x minus 36 dx. After that, we need to integrate in terms of x from the limit -1 to 1. So we got negative x cubed over 3 plus 13x squared over 2 minus 36x. And we plug in the -1 and 1. And finally, we got negative 218 over 3. So that's all for our presentation for SEL. Thank you.